Hello guys, welcome back. Continuing from our lesson last week, which was rational numbers, right? The last lesson in math that we discussed about is rational numbers. Today we're going to discuss about the rational numbers that can be written as decimals, okay? Which can be described as either repeating decimals or terminating decimals. So what do I mean by those? What is a repeating decimal and what is a terminating decimal? So a terminating decimal are those that stop, okay? Decimals that stop, which means their remainder reaches zero if you divide them, okay? Now, what is a repeating decimal then? Well, it's quite the opposite of a terminating decimal. So instead of stopping, it just continues on forever, right? So those repeating decimal are those which continue on forever. The remainder never hits zero. Okay, so it basically repeats a certain pattern or a certain number. So for example, 0.4646464646. So it's going to repeat 46 over and over again. Or sometimes it's 0.33333333. Yeah, so it repeats a certain pattern or it repeats a certain number. Okay, and it never reaches zero. So here we have some examples. Can you identify which are the repeating and which are the terminating ones? I'll give you a few seconds before we answer together. Okay, welcome back. So for the first one, since it ended, right, as you can see, 0.6 and nothing else after that, it means it is a terminating decimal. For the second one, seem to be just repeating, right? It's just repeating 4, 6, 4, 6, 4, and then we probably, after that, it will be 6, then 4, then 6, then 4, then 6, right? So I think we can say that it is a repeating decimal. For the third one, we have another terminating one, because after 5, nothing is there, right? For the fourth one, we also have a terminating, and then for the last one, we have a repeating, because it's only 3, 3, 3, 3, 3, 3, like I said earlier, right? Now, identifying a terminating from a repeating looks pretty easy, right? Yes, it is easy because you just need to find the decimal which keeps repeating, as I told you earlier, right? But another giveaway, another big giveaway is this, as you can see over here, right? So the terminating doesn't have an equal sign, then a number, and then a bar on top, right? As you can see, the terminating ones doesn't have those. But for the repeating, we have those. So what does that mean? Okay, the number with a bar, okay, the number with a bar on top identifies that it is in fact a repeating decimal. Since you'll only be using the bar, right? You'll only be placing a bar on top of a certain number if it will continue infinitely, right? As I have explained a while ago, that there, for example, we have 0.333333333. It will go on forever and ever, right? So instead of writing 0.3 and you can't write 3 forever, instead of doing that, you just have to simply say 0.3 and put a bar on top. That will specify that that 3 is going to repeat forever and ever and ever, right? So that's the main difference between repeating and terminating. Terminating always ends, all right? So it is also very important that you know how to actually change a decimal to become a fraction and a fraction changed to a decimal, right? So continuing forward, we'll be discussing how to change a decimal to a fraction. Okay, so we have also studied about place values, am I correct? So it says here, read a decimal using the correct place value. How do you say it determines the fraction? So how do we read this again? We read it as 2/10, right? Because in the decimal place value, we have tenths, hundreds, thousands, and then so on and so forth, right? So we read this as 2/10, right? So that is already the giveaway of the fraction. How you write it as a fraction? 2/10, because you say 2/10, right? 2 will be on top and 10 will be on the bottom, okay? Now, how do you do this vice versa? How do you do it from fraction to decimal? Well, it's quite simple, right? You divide the numerator by the denominator, meaning that whatever is on top, you'll be dividing it by whatever is in the bottom, right? As you can see here, we have, oh, sorry, 4 divided by 5, right? Now, we can't solve this right away because you cannot divide 4 by 5, right? So what we'll be doing, we'll be adding a 0 and we'll be putting a decimal point on top, right? And we'll put 8 because 8 times 5 is 40, and that gives us a 0, right? So we know for a fact that this is a terminating decimal, right? So it also means that 4/5 is equal to 0.8. Now, why was there no 0 here? It's definitely up to you if you want to add a 0, so you won't get confused. But if you don't want to add a 0, that's also fine. Because once you have a point and there's no number on the left side of the point, that means that it's 0. Okay? So you can write it as 0.8 or 0.8. It's up to you. But in proper usage, you have to write a 0 there, so other people won't get confused. Now, here's another example. We have 3/4, which is going to be 3 divided by 4. What's going to happen next is we're going to put a decimal point, right, and the 0, and we're going to bring down, and then we're going to multiply 7 into 4 to get 28, right? And then we'll get 2 as our answer, as our remainder. We have to add another 0 because it cannot be, right? You cannot divide 2, you cannot minus 2 by 4 or else you have a negative number. So yeah, we add another 0, then bring that down. Then we can divide 20 by 4, right? Which is going to be 5, which is going to be 20, and we're going to have 0 remainder again. 3/4 this time is equal to 0.75. Again, the 0 is mandatory when we're using it in proper term. But if you're solving and you don't want to place a 0, it's all right. So here's another example. This time 1/3 will become 3/1. 1 divided by 3, right? So here's the full description of that. As you can see here, the first thing we did was to add a point and then add another 0, right? That would give us the opportunity to divide it, right? So 10 divided by 3 is 3. Okay, then we will have 9. Then 10 minus 9 is equal to 1. Then we add another 0. And then, as you can see here, this is what a repeating decimal looks like. Okay, so if you pay attention to this, you can see that there's a bar on top of this 3. Because it will never end. As you can see over here, 1, 0 started, right? And then if you minus 10 to 9, you'll get 1, right? And then you add another 0, bring that 0 down, and you'll use the same 3 to get 9. And then you'll get 1 again, and then you add another 0, and then you bring that down, and you get 10 again, right? So it will never end. This is the repeating decimal, right? So this can be written as 0.3 with a bar on top. Okay? So this defines, or this means that 3 is repeating. Okay, it's a never-ending problem that keeps repeating 3. So it's 0.333, etc. All right. Here we have another example. Okay, this time 3 divided by 5. We add another 0. We get 6. All right, 6 times 5 gives us 30, which will end the equation right there. So we have 0.6 on this one. All right. Yeah. So to explain it further, 1/3, right, means 1 divided by 3, right? That's what I said a while ago. So it's going to be like that. And then you're going to know it so on and so forth. You're going to write 0.3 bar or 0.33 bar. It doesn't matter. Okay. Okay. But when you're writing it in proper term, you need to write it as the basic or the simplest form, which is 0.3. Okay. You only need the simplest form. If it's a pattern, then you need to find a pattern. 5/11 means 5 divided by 11, right? That means we have 4, 5, 4, 5, 4, 5. And we have 4, 5, 4, 5, 4, 5, right? But this is not going to be allowed again because we need to make it simpler. We can write it as 0.45 bar, right? So that's the simplest form you can get. Here we have another example, 5 divided by 6, right? Now this time, as you can see here, 0.833333, right? But you cannot write it as 0.83 bar because that means it's going to be repeating 8 and 3 alternately. So 83, 83, 83, 83. You cannot write it because as you can see here, it's only repeating 3. So this is going to be wrong. 0.833 bar is not so wrong, but again, we need to write it as simple as possible. So this is also wrong. And the correct answer would be 0.83 and then a bar on top. All right. So then how about if we have another example, right? So 0.4166, again, 6 is the only repeating one, so you only need to put a bar on top of the 6. And that ends our lesson for today.